Hello and welcome. In today's session, I'm going to be walking you through creating, animating the Hilbert's curve in Blender. So, yes, this is what we're going to do. And first thing first, Hilbert's curve is a recursive algorithm, and yeah, that's something about Hilbert's curve. And to start off, since we are going to be using Python, we have to install the Blender Python module. And then another function that we will use is the power function. We'll get that from math. And then uh, in Hilbert's curve, we have something we call order, order of the curve. And that this is just a variable we will use to determine the complexity. Here we are just using 3 as an example, but you can use a value from 1 to any number basically. But just for, we will change that to show how it actually works for different values. So we define the order. We start with 3. After that, we'll calculate the number of points in the curve. Calculate the curve. So n, we will use the variable n, and to get it will be the power of 2, not z, 2, then the total number of points will be gotten by multiplying n by itself, just like okay, I don't know why I'm doing that, n squared. Now this is the total number of points that the curve will have. Okay, and now we have to define the function that will actually generate the Hilbert curve points. Function to generate the Hilbert's curve points. We will just name it Hilbert, where it will take a value I. Okay. Okay. I don't know. Okay. Yeah. And here we will define the initial points. We will define the initial points to the curve, where the points will be, let me just close this one before I forget. The first point will be 0, 0. The second point will be 0, 1. The third point will be 1, 1. And the fourth point, and the last one, will be 1, 0. So now that we have declared the points, we have to get the index for the current iteration. And to do that, we're going to say index equals to I. Yeah, so, and then we initialize the point based on the index. We will use a variable v and points index. The index we have just this one we have gotten for the current iteration. After that, we have to loop through the iteration, loop through. Okay, this is a comment. loop through the iteration. And the reason we are doing this is now to generate the points. And we will use a for loop. So for j in range I, for j in range, not I, but rather 1 to order. Is it order or total? Order. The order of the curve. What are we going to do? First of all, we have to shift the index by 2 bits. Shift by 2 bits. Yes, and how we're going to do this is it will be I shifting to the right 2 bits. After we have shifted, we get the new index for the current iteration, the same way we got the index here. Yeah. So we have gotten the new index for the current iteration, and now we have to calculate the length for this iteration. And calculating the length will be 2 power the iteration, the jth iteration. So 2 power for j in the range. So the value of the 2, the length of this iteration will be 2 power the number of iteration we have. So it will be from 1 to order. So it will be 1, 2, or 3. Okay, that is the length of this iteration. So after that, we have to determine the transformation based on the index, this index we have just determined of the current, based on the index of the current iteration. And to do that, remember, index can, we have, okay, let me just do it and then explain later. We have index can be 0. We also have another case where index can be 1. The index can also be 2, or the index can be 3. So for all these cases, we have to determine a point. Okay, we have to determine the point we initialized based on the indexes. Remember, this is the point we initialized, v. So depending on all these cases, v will be a different value. So if the index is 0, the value of v will be the index 1, v index 0. Let's see, what if the index is 1? So if the index is 1, this one will be 0 and this one will be 1. And remember, we have to add the length here. Remember this length, we got the length of the iteration. Okay, we have to add it there. And if the index is 2, let us take this one because it will be kind of similar, and v will be the 0th index of v plus the length Okay, and for the second coordinate, it will still be the same. It is, yeah, it is similar. And if the index is v, here now we will, for simplicity purposes, we'll use a temporary variable. So the length minus 1 minus v 0, the zeroth index. And now let us see. Uh, no, it will be slightly different. Uh, slightly, this one will be 1 for the first. And okay, I'm supposed to add the length here. And then for the second coordinate, we will use the temporary. Okay, since we have already declared it, let us use its variable name. And now we have calculated the value of v for all the possible cases of the index. Now all we have to do is return the value of v. Okay, are we together? So after that, now we have to generate the curve points. Generate the curve points. Remember, yes, this is the function to generate the curve points. And now here we are going to call the function. Okay. 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 Yes. So it's supposed to be out here. So we will use path where we will call our function I for all the points. Okay, in range total. So basically what we are doing, we are calling this function Hilbert for I in range, okay, in range total. So for all the points, the total number of points, okay, we are calling the function and setting it to a variable path. Now we create curve object and set its data. And now how do we do that? We use curve data, not curve. The curve data we will get it by using the Blender Python module. Data.curves.new. We have to give it a name. Let's just give it Hilbert curve. We close that, and we have to specify the type of data. It is a curve, don't forget that, and we close the brackets. And now another thing we have to set is the dimensions. Here we are going to render a 2D there's something we call spline, and this is how we get curve. Now for the spline, the points we have to add the length of the path. Remember to close all the brackets there. And now after that, okay, so here we're going to go for I enumerate path. Remember, path is what we got here, okay? Not path P, path. Spline dot points for the I dot co dot core will be equal to x, y, 0, and 1. Okay. After that, we now have to create the object. Okay. I believe this is the last part. And the curve object obj, we get it by using the Blender Python module to get the data of the object. Remember the name we specified, we have to pass it here. And then we pass in what we want to render, the curve data which we defined here. Okay, we pass it there, and then now to finally render it to the context. Okay, this should be an underscore because we are passing this, the curve object. And let us see how our code will run. Okay, I'm getting an error. I don't know why. Oh, okay. Unexpected indent. Okay, I believe that is fixed. Uh, okay. Indentation error. Okay, I believe I have some errors with my I will have to re-indent. Okay, I don't know if it is. Yeah. And now this is what we have rendered for the order 3, and let us see how it does for a different order. Let us try order 4. Let us first delete this. Yeah. Remember, the order variable is what is defining the complexity of our curve. Yes, and here it is. Yeah, and that is all, and hope it was beneficial to you. Thank you.